Hello, so for today we're going to tackle my laboratory exercise number 4, which is the Newton's method using MATLAB. The introduction of this activity is it will allow students to implement Newton's method using MATLAB, Mathematica, or similar software. And the objectives are at the end of this activity, the students are expected to have been able to construct a function script using MATLAB, demonstrate your understanding in Newton's method, understand and implement Newton's method to find the root of a function using software. And the materials needed are MATLAB, Mathematica, or similar software. Procedure number 1. The pseudocode can be found in Numerical Mathematics and Computing, 6th edition, Wargene, David Kincaid, page 92. Procedure number 2. Demonstrate Newton's method using MATLAB and calculate the roots of a user-defined function with the following specifications. Procedure number 3. Put all these codes on a *.m script or suite of scripts that is loaded in MATLAB. The MATLAB function should accept the user-defined function as an input argument and procedure a variable containing the answer. For example, y. This is my laboratory exercise 4, and I want to write the program for implementing Newton's method where we avoid a division by zero that allows maximum number of iterations that avoid extra evaluation to the function of x. So I've been trying to make the program from a reference work, but it seems that my MATLAB here didn't read the pseudocode, so I made this from a research and some help from our forums. We would try and solve a function x squared minus 9 is equal to 0, and we've entered the function here to know the number of iterations errors. The potential division by 0 is done by a try-catch construction, which works follows first MATLAB that tries to execute the code in the try block, but if something goes wrong, then the catch block is executed instead in next execution is terminated by exit here. The division by 0 will always be deducted and the problem will be stopped. The main purpose of our way of treating division by 0 is to give the user a more informative error message and stop the program in a gentle way, calling exit. With an argument different from 0 signifies that the program stopped because of error. It is a good habit to supply the value of 1 because tools in the operating system can be used by other purposes that the power program failed to prevent an infinite loop because of their work divergent iterations. We introduced the integer a variable iteration counter here. We can still extend the condition in which such no more iteration that face 1 the number of iteration which has 200. Well, easily let this limit be an argument to the function rather than a fixed constant. The Newton function returns the approximate solution and number of iteration. The lottery is equal to -1 at the convergence criterion of the absolute value of x is less than epsilon was not reached within the maximum number of iterations. In a code, before we print out the solution and the number function cost, the main cost of a method of solving f of x for 0 equations is usually the evaluation of f of x and f prime of x. So the total number for this function is an instant interesting a measure of the computational work. Please note that in the portion Newton here is an initial call to f and x and then one call to f and the one to f prime init situations. Running a Newton's method, we get the following clip out on the screen. And here, when we now run our program, the number function of cost is 25. In the solution in our initial problem of x squared minus 9 equal to 0, so our answer to our solution is 3.000000. And that would be all. I hope you've learned a lot for today about our Newton methods. Have a good one.